Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of gravity and extreme environments like never before. These are the challenges we face to push the bounds of humanity.
Heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful
NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently away for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor
And be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth
Water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
To prepare us,
Solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for human preparation as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
Imagine if you were an alien who, was visiting the Earth for the first time from some other galaxy. Imagine only visiting the
landing on Earth and getting rocks from Kansas. It would give us insight into one particular location on the Earth, but not at all the
Artemis astronauts will fulfill a different mission in a unique environment. While the Apollo astronauts who visited the moon's surface between called South Pole Aitken, it takes up almost a quarter of the moon and is so deep it exposes portions of the moon's interior.
We think that there was this increased period or very intense period of huge material hitting the surface of the moon, creating these would kind of help us bracket that early period of time.
The moon's South Pole region has resources that are vital for long-term exploration. Because the moon is bare sunlight for extended periods of time to harness for power. At the same time, the bottoms of some deep craters are shrouded in constant darkness. Scientists
Over time, there's individual molecules of water and carbon dioxide and other gases that actually
perspective. If we can understand just how much water there is and where it is and how to get it out of the regolith of the moon, we can turn it into really important things like drinking.
7 instruments. LRO has mapped the moon's temperature, geology, radiation environment, and is providing insight on how the moon is changing over time.
LRO is this incredible mission. It was launched in 2009 as the opportunity to go back to the moon to create this.
LRO's elliptical orbit was closest to the moon during the spacecraft's pass over the South Pole. So scientists have more information.
That database. Incidentally, the LRO data volume is now over 1.3 petabytes. It's the largest volume of data that NASA has ever collected from special maps. We share them with the public and we share them with the various engineers and scientists who are going to help enact and make Artemis a reality.
This is basically
interesting areas to visit nearby.
So it's my real belief that we have an opportunity with Artemis to do something different than Apollo. We build on Apollo, we learn from Apollo. Individual missions, but a much larger program that eventually will result in the ability to go onto Mars.
Mars is quite a bit longer away from our own planet than conduct exploration for longer periods of time is going to be critical for Martian exploration. And lessons learned for that sustainable type of exploration start right here at the moon.
Desire to explore, I think it's in all of us and certainly in us as a society. And so I think setting our sights on something and accomplishing this goal together of what we're doing that we can't ignore as well.
I have 3 kids, aged 10, 6, and 2. I also look at my daughter, and I think, okay, Amelia, you know, she keeps saying she wants to be a firefighter, a construction worker, and an
So why is the moon my favorite body to study? I think growing up, you could always see it in the sky. Neighbor, and you can even with the naked eye, you could start picking out features on the moon. I think that was really cool, you know, this foreign planetary body, you know, looking at images like the one behind me here I think that always blows my mind.
But moon, and just the fact that he can look up and see, oh, moon, that makes me so happy.
A land of pristine waters, enormous glaciers, and ancient geology. And for some, the site of a hotly contested claim of the oldest signs of microbial recently published findings of possible stromatolites, or microbial fossils, dating back to 3.7 billion years ago.
Greatly the case with this one. When I came to see them after that paper was published, I very much doubted that interpretation, and I thought, well, we need to do 2 things. One, we need to put a paper out, and secondly, we need to do a work.
Extraordinary claims require extraordinary evidence, and a finding like this requires further investigation. Dr. Allwood has gathered it.
Made a claim that there are biosignatures in the form of stromatolites in these rocks, and there's another group of authors, I happen to be one, sense of the geology that surrounds those potentially stromatolite-bearing outcrops and try to get a sense for what the ancient environment looked like at the kinds of life in Earth's geological record by a couple of 100 million years.
It means that the window of opportunity for life to emerge doesn't have to be very big. Only also had to maintain its conditions, its sort of cradle of life, its opportunity for life to emerge for that short period of time. It didn't have to sort of maintain it.
What that earliest life was like. So the record that we have from geology is in these rocks that are very difficult to interpret.
Camera, and you record your observations, and when you think you've zeroed in on a piece of rock that might be worth taking back to the lab, you get your trusty rock.
We look for things in the rock that cannot form without the influence of life. They can change the chemistry, and they actually change this.
Here, what you need to do is look at the context of the rocks around those stromatolites and try to get a sense for what that geology is telling you.
This is our sample here. You shouldn't see it on the back of the sample. You shouldn't see it in the back of the hole there. That's about 14 centimetres depth hole. And you're still seeing the structure there. Back, so it's at least that distance in length. It's not a cone shape at all.
A lot of times when you're looking for something that's good at preserving clues, and my job as a geologist is to take those little bits of information and see if I can make a story about what happened in those. The clues have just been lost through time.
After investigating the site thoroughly, the team concludes that there is insufficient evidence of life